please take a seat. The chair of the session, gracias. Quizá lo digo en español por las personas que se encuentran mejor en español. Vamos a ver, yo solo soy una persona de la Red Europea Invisibles y lo que quiero hacer es introducir al chair, porque al chair al moderador, introduce a los demás. Entonces, tenemos hoy para esta sesión Arte, Ciencia de moderador a Hitoshi Murayama. Hitoshi Murayama es uno de los líderes mundiales, es un físico teórico y es uno de los líderes mundiales en búsqueda de física nueva y también en los límites, física de partículas y sus límites con cosmología. Ha trabajado también mucho en neutrinos, etcétera, y es un honor que nos haga de moderador. Hitoshi es profesor en la Universidad de Berkeley y también ha creado y es director del Instituto de Física y Matemáticas del Universo en Tokio. Y bueno, pues paso la palabra y la gestión de todo esto. Hitoshi, muchas gracias.
Okay, thank you for the introduction, Belen. I did not understand anything she said. I believe it was a nice thing you said about me. So anyway, thank you for coming to this event. And this event is a really very interesting event where science and art are meeting with each other. So it is in conjunction with this the workshop that just finished called Invisibles Meets Visibles. And we're talking about many invisible things in science. You'll hear more about it as we go on. Dark matter, neutrinos, dark energy, and we are studying these invisible things, which are actually very, very important for us to understand how universe began, how it evolved to what is today, and where it's going from now on. So that is a subject of the workshop that was just finished. But at the same time, this museum graciously and generously hosted this workshop. And so we have this event now where artists and scientists can meet with each other and seek for common grounds. I'm sure there are also different aspects as well, so that we can actually have seek interesting connection between art and science. And the main theme of this event is actually extra dimensions. And this is just sort of an artistic conception of what extra dimensions might look like. More will come up later on. And just in case, I'm worried that if you came here thinking the scientists are supposed to look something like this, clearly that is not the case. So I hope you will see sort of human aspect of science when you actually get to listen to our talks from this point on. And you are really in for an incredible treat. The 4 speakers we got today are known to be not only great academics, but also fantastic communicators to the general public. And first speaker is Mario Livio, who is an astrophysicist. I'll tell more about in a moment. And followed by Fabiola Giannotti, she's an experimental physicist. And Linda Henderson, she's an art historian. And after the break, you get to hear also from Lisa Randall, who is a theoretical physicist. So rather than me spending a lot of time, I'd like to just go ahead and introduce the first speaker, Mario Livio. And he's a theoretical astrophysicist. He was born in Romania. I understand that he actually had to move to Israel at the age of 5. I'm sure that's a very difficult time back then. And got his PhD in Tel Aviv University, had a position at Technion, then eventually moved to Space Science Institute in the Johns Hopkins University. This is the institute that operates the Space Telescope, Hubble Space Telescope. So you probably know about this telescope. And so that's what he does. And he's been very active academically studying black hole, dark energy, and many interesting other subjects. So that's what he has been doing. And I have to show one more slide. Please come back. And one more slide is this one. So this actually shows the kind of books he has written for general public. And this book on the golden ratio has been very popular. It has a book on symmetry. And I can also tell he has a good sense of humor. When he had a blog article, he's an avid blogger as well, he put together a blog article on symmetry. He took a picture of himself like this. So you can tell he has a good sense of humor. So please welcome Mario Livio.
Thank you very much. So it's a pleasure to talk to you, and what I want to talk to you about is our place in the cosmos, because you will see that this connects to a number of things that philosophical and otherwise that we think about. So let's start with our solar system. We are one small planet in our solar system, which contains 8 planets. Pluto is no longer considered a planet, but I actually do have it here. And next month, actually, a spacecraft is going to reach Pluto. So this is why I had it here. Now, the Earth is one of the smaller planets, actually, in our solar system, and not a very important one. I think you will all agree that the most beautiful planet is actually Saturn. Now, Miro, the painter, had this painting about the beginning of the world. And of course, he really had in mind only the solar system, the Earth, and what's happening on it when he painted here something like the sun, a human, a dog, and things like that that appear in this. Just to see how beautiful Saturn actually is, not only it has these spectacular rings, but it also has moons moving around it. And in this short film here, you can actually see the moons, how they are moving. You see the shadow of the moon on the surface of Saturn. You see 2 moons coming into view, and as soon as they come there, you can see their shadow as well, moving on the face of Saturn, which of course makes for a fantastic image. There is another moon going out there along the rings in that direction. Now, if you look at planets in general, we now know that our solar system is not the only one that has planets. This is the first planet we managed to actually image directly. This is around the star Fomalhaut, and we actually managed to follow it for a few years in its orbit around Fomalhaut. And planets now, we know, actually are formed in pillars of gas and dust like these ones here in the Eagle Nebula. This is an image taken with the Hubble Space Telescope for our 25th anniversary. I think you will agree with me that this is in itself looks almost like a work of art, but it's actually something that exists out there. But there is art that resembles this. Thomas Moran, who painted the West in the US, I mean, just look at this. I mean, here, look. Oops. Here and here. So you can see these same type of themes that appear actually in the US West, appearing also, you know, in places where new stars are being born. Now, I told you that there are now many known planets. It's amazing that until 1992, we didn't know of a single planet outside the solar system. In 92, we discovered 2 planets, but they were around a somewhat bizarre star we call a pulsar. Only in 1995 have we found the first planet that is moving around a sun-like star. At this point now, we know of more than 3,000 planets moving around other stars. And we actually know that in our Milky Way galaxy alone, there are probably 1 billion planets like the Earth moving in what we call the habitable zone of their star. This is the region that allows for liquid water to be on the surface of the planet. And the reason that's important to us is because we think water may be essential for actually starting life. So from being this planet that was supposed to be at the center of the universe, we have now moved to a situation where we are a small planet, not at the center of our own solar system, and there are 1 billion of planets like ours in our own Milky Way galaxy. Now, in the Milky Way galaxy, there are a few 100 billion stars like the sun. So this is, you know, it shows you how our physical existence starts to become smaller and smaller. And in fact, we know that there are many other galaxies, just like the Milky Way. Some don't look exactly like the Milky Way. The Milky Way is a spiral galaxy like the one at the top left there, or somewhere between the top left and top right. But there are these other galaxies. And we now actually know how many galaxies are in the observable universe, because we have taken this image with Hubble. This is the Hubble Ultra Deep Field. Now, the amazing thing about this image is that with the exception, you see this, where you see these kind of spikes there, there are about 3 of those like this in this image. Here is another one. But other than those are stars. Other than those, every single point of light you see here, you know, like this point or that point, it's a whole galaxy with 100 billion stars like the sun. And there are about 10,000 galaxies in this image. And do you know how much this image occupies in the night sky? It's about the area that you would see if you look through a drinking straw. So you look through a drinking straw, you see these 10,000 galaxies there. So you can actually multiply by the area of the sky and discover that in our observable universe, there are a few 100 billion galaxies like the Milky Way. So we started with being at the center of the universe, discovering we're not the center of the solar system. Our solar system in our own Milky Way galaxy is not at the center. It's 2/3 of the way out. And there are hundreds of billions of galaxies in the observable universe. So this starts to look a little bit depressing, you know, that, and so, but it gets only worse. So, you know, we can fly through this universe because we know the distances to these galaxies that I showed you. So we can fly through them. And when things end here, it's not because there are no more galaxies, but we just reached how far we can see with our telescopes. So we can fly through that. Now, why did I say that it gets even more depressing? The reason is that, in fact, this, by the way, shows you something. This should not have appeared here. But that's okay. I'll come back to that. All the matter of all the stars, planets, the gas in galaxies, and the galaxies themselves, and so on, that is less than 5% of the energy budget of the universe. About 25% is in the form of something we call dark matter. Dark matter is matter that does not shine. It does not emit any light. It does not absorb any light. So how do we know it's there? Because we see its gravitational effects. It is actually holding galaxies together and clusters of galaxies together. And in these images that you see here, dark matter is denoted by this blue stuff here. And the red is the real gas in those clusters of galaxies. Now, how do we see that blue things if we cannot actually see it? There is a trick that we use, which is called gravitational lensing. And this is something that Einstein taught us. You see, if I look at a very distant galaxy, and between me and that galaxy, there is a cluster of galaxies in the middle, Einstein taught us that light from the distant galaxy will be bent by the gravitational force of this intervening cluster. So the cluster will act like a lens. It just produces lensing of the light of the more distant objects. So by mapping this lensing, we can actually determine the distribution of the dark matter. And the same is true in this. This one is one that we see kind of face on, where the two clusters are colliding like this. So that's about 26% of the energy budget of the universe. But it gets even worse yet. Namely, about 70% of the energy of the universe is in the form of something we call dark energy. Now, that's something we don't see at all. It is something smooth that permeates all space. And how do we know that's there? Well, we know that's there because we see that the expansion of our universe is speeding up. This was only discovered in 1998. Our universe is speeding up because this dark energy actually pushes our universe to accelerate. Now, how can we find something like this, that the universe is accelerating? We look at very distant explosions. You see here this point of light that appeared there? This is a supernova explosion. Now, if we look at such a explosion that is, let's say, 7 billion light years away, it means it took light 7 billion years to get to me. It means I actually get a snapshot of the universe as it looked 7 billion years ago. And I can then compare how the universe was expanding then to how it is expanding now, and I discovered that our universe is accelerating, propelled by this dark energy. So let's stop for a second and see what happened. Once we were at the center of the universe, then we became a small planet in our solar system. Then our solar system is 2/3 of the way out in our Milky Way galaxy. Then there are hundreds of billions of galaxies like the Milky Way. Then all the stuff that stars, planets, gas, and so on in galaxies, and we are made of, is only 5% of the energy of the universe. 25 or so percent is dark matter, 70% is dark energy. Now, if this does not look depressing enough, there is even one step further, which is there are some speculations that our entire universe is but one member of a huge ensemble of universes. How many universes? One followed by about 500 zeros. So now that's a speculation, but serious people are thinking about this. That our entire universe may be just one out of this number, one followed by 500 universes. Now, the picture of Kandinsky that I had before was actually referring to this one, because it almost seems as if Kandinsky anticipated this and painted his circles that look just like this painting of the multiverse. Now, if what I told you until now really depresses you, that we are just a speck of dust in the grand scheme of things, you shouldn't be depressed. And I'll explain to you why. First of all, we literally are stardust. Namely, all the stuff in our bodies, carbon, the oxygen, the iron, all that, was actually formed inside stars. It did not exist from the beginning, from the Big Bang. Only hydrogen and helium and a little bit of other things existed. Everything else was formed in the universe. Not only that, one atom in my body may have been formed in that star, and another atom may have been formed in that star. So the way that that works is from this gas and dust, new stars are being born. Then those stars produce the carbon, oxygen, iron, and so on. Those stars either explode as supernova explosions, or in a gentler process, which we call planetary nebula, eject their outer layer into the interstellar medium, and from that, new stars are being born, and planets and us. So, here is the key phrase here. Not only are we in the universe, but the universe is inside us. So we are, in that sense, extraordinarily central to what's happening in the universe. But even that is not all. There is another, maybe even more important reason. And that is the following. First, you know, our last bastion for being special in the universe is that so far we only know of life on Earth. We are not aware yet of life anywhere else. But is that really the only place? We don't know that, but I can tell you that with the efforts that we're now making, we may be able to answer this question within the next 2 to 3 decades. Within 20 to 30 years, we will be able to answer the question, is there life elsewhere? So it boils down to how special is the solar system. But here now is the main point that I want to make. This is Copernicus. When Copernicus discovered that we are not at the center of the solar system, it is us, humans, who discovered that. When Charles Darwin suggested that we are nothing special, but rather a normal product of evolution like everything is, it is another human who discovered that. When astronomer Harold Shapley discovered in the last century that the solar system is 2/3 of the way out in our galaxy, it's a human who discovered that. When Edwin Hubble, after whom our telescope is named, and we're celebrating now 25 years, discovered that there are many other galaxies other than the Milky Way, he discovered that. And with the telescope that is named after him, we discovered these hundreds of billions of other galaxies. So the universe, if you like, has expanded just as fast as our minds did. Our minds are the minds that gave us all this new knowledge. And when my friend Alan Guth suggested that when the universe was a tiny fraction of a second old, it has undergone this stupendous expansion, which maybe gave rise to this multiverse, to this ensemble of universes, it was again a human who suggested that. So we are just a speck of dust in terms of our physical existence. But we are absolutely central to everything that we have discovered. So I'll just finish now with this drawing, famous drawing from Leonardo. Leonardo liked to talk about the microcosm and the macrocosm. To him, the microcosm really meant the human body. Today, when we talk about the microcosm, and Fabiola, who will talk after me, is involved in that, and Lisa Randall is in understanding the subatomic world, the world of the most basic particles in nature. And the macrocosm is this universe or multiverse even at large. So we have reached this point where we actually can talk about the microcosm and the macrocosm in terms of human understanding. So humans are absolutely central to this picture. Thank you.